Hi everyone, welcome back. We're going to look at solving inequality examples in this video. And let's start with a compound inequality. What follows are some examples of ways inequalities may be observed in real life. The first example is an introduction to and inequalities. These are called intersection inequalities. And I'm going to read the scenario first. Two truck drivers are en route to their given destinations. The truck driver 1 is leaving Moses Lake, Washington at Interstate 90, milepost 166, heading toward Montana. So I'm just going to go ahead and make a line that represents I-90. For those of you who have traveled Interstate 90, you will know that it's not that curvy. For most of the trip, it's just an east-west interstate. Now, we'll call this right here Moses Lake. We'll represent that with ML, and we're going to call that milepost 166. And the truck driver is heading toward Montana. So those of you who are familiar with the U.S. map know that Montana is to the east and Seattle is over here toward the west. Now, truck driver 2 leaves Spokane, Washington at milepost 270. Now, this is helpful even if you're not super familiar with Washington State because we know that milepost 270 is Spokane. So it has to be further east than Moses Lake. It can't be toward the west because if you've traveled I-90, you know that as you head toward the west, the milepost numbers get smaller. So this is Spokane. And this is at milepost 270. Now this person, this truck driver, truck driver 2, is leaving Spokane and drives towards Seattle. Okay, so now we need to list the direction these two trucks are going. So truck 2 leaves Spokane and heads west. The truck driver 1 leaves Moses Lake and heads toward Montana. And I'm going to use a slightly different color here so you can see the two lines a little better. And I'm going to include the endpoint, so I'll just make a dot. So I'm using a brown pen for the Spokane truck driver and blue for the Moses Lake truck driver. Now, what I'm hoping you notice is that there is some time on the interstate where the two truck drivers will have driven the same stretch of freeway or interstate. How many miles of overlap on I-90 will the two truck drivers share, or where would their path overlap? So if you think about this, there is a section from milepost 166 to milepost 270 where the two truck drivers will be traveling the same stretch of interstate. Can you list this interval in interval notation? Well, certainly. I know that the two endpoints are included because the truck drivers were both at those intersections or mileposts, so we include the endpoints. And that means that it will be two brackets. We know that the milepost 166 is the starting point and milepost 270 is the ending point. Notice I used brackets on both sides to enclose my interval. Also notice that there are no breaks in this interval where the two truck drivers traveled the same stretch of road. In example 2, we have an introduction to an OR inequality, which is also called a union. And you can remember that if it's a union, you use the U or U grouping to connect one separate piece with another separate piece. That union says there was a break, but we're going to list all the values that are true anyway, even though there was a break in the continuous solutions. A person with diabetes must monitor their blood glucose levels while fasting, not eating food, to ensure they do not become ill. The danger zones for low glucose levels are when insulin levels drop below 80 milligrams per deciliter or higher than 120 milligrams per deciliter. Now you might be thinking, I don't know what those units of measure mean. That's not really the point of this scenario unless you're going into medical field. If you're going into the medical field, that might make sense. So what we need to do is graph the danger zone intervals as a compound inequality. So let's first highlight the information. We know that the insulin levels dropping below 80 or are higher than 120 will cause issues. So let's go ahead and list these on a number line. First, let's make the number line. Negative infinity on the left, positive infinity on the right. I'm going to list the two values where there are issues. Below 80, so to the left of 80, which would mean an open dot at 80. I'll go ahead and just do that and use an open dot notation. And higher than 120, so we'll call this other point here 120, and we'll also use an open dot on that one moving to the right. So these are the intervals on which there are issues with blood glucose levels and you need to be concerned. And a person that does not have a diabetic health concern would hopefully have that regulated fairly well by their own body, which is what your pancreas does. So graph this danger zone as a compound inequality. Well, we have to first list the interval where this is true. This danger zone is true, negative infinity to 80. And that's an open dot, so a parenthesis. There's a break right here. So that means there's a union between the two pieces of interval. Then open paren 120 to infinity, close paren. So this would be the interval notation you would use. I'm going to go ahead and just select this and move it over. Now we need to list the union in interval notation. So this was the compound inequality first. So let's put that down here. I put these in the wrong order. So let's do the interval notation first because that's what you're familiar with. And then on the next part it says, can you graph this danger zone as a compound inequality? So let's do the inequality part. We know that the insulin levels is what we're talking about. So we'll call this an I, insulin. And we'll say insulin is less than 80. Or, now we're talking about the other piece, the insulin is greater than 120. Now, scientists would be screaming because I'm not using the units notation on these. So I'm going to go ahead and list the units with this so that my colleagues don't have issues. Or I is greater than 120 milligrams per deciliter. There we go. See you in the next video.